Hi everyone, we're going to talk about polygons today. So this is lesson 3.3. A polygon is defined as a closed geometric figure formed by connecting line segments at the end points. So these five figures here are all, they're all polygons. Um, they're all made with straight lines and they're all closed. So here are a couple of non-polygons. So if I have a straight line and a straight line and a straight line, but they don't meet, that's not a polygon. If I have some straight lines like this and then I have a curve, that's not a polygon. Okay, it's all straight lines. Um, we can break polygons down into two categories. One is convex polygons and one is concave polygons. So concave polygons have a dip in them. Like it goes inside. Um, uh, we're not going to talk about concave polygons. We're only going to talk about convex polygons in this course, okay? And then the other words we have are the sides of the polygon, so that's the straight line segments, and the vertex is where the ends meet, okay? Okay, let's talk about the interior angle sum of a polygon. We know that the interior angle sum of a triangle is 180 degrees, right? Doot, doot, doot. We know that the inside angles of any triangle add up to 180 degrees. So if we were to take a four-sided polygon and cut it down from one vertex to the opposite vertex so that we have two triangles, well, if we look at this upper triangle, we know that those three blue angles equal 180 degrees. And we can look at this other triangle, and its three angles have a total of 180 degrees. So for our four-sided polygon with two triangles, the interior angle sum is 2 times 180, which is 360. And we actually already know that because picture a square or a rectangle. We know that that's got four right angles, okay, and 4 times 90 is 360. But that sum is the same for any four-sided polygon. If we look at a five-sided polygon, we now have one triangle, two triangles, three triangles. So our interior angle sum is going to be 3 times 180, which is 540 degrees. And if we have six sides, we can split that into four triangles, and our interior angle sum is 4 times 180, which is 720. So this brings us to our first theorem on polygons, and that is that the interior angle sum of an n-sided polygon, which means a polygon that has n sides, the sum of the interior angles of that polygon is 180 times n minus 2, as long as n is greater than 2. Okay, so that's what we've got here. We've got six sides. That gives us four triangles, so it's 4 times 180, or 180 times 4. I just wrote it the other way here. So the number of triangles is always 2 less than the number of sides. So n minus 2. Okay. All right. Polygons can be equiangular or equilateral. So this rectangle is a polygon that is equiangular. All four angles are the same. They're all 90 degrees. But the sides are different lengths. And this is an equilateral hexagon. All the six sides are the same length, but the angles are very different. If we have a polygon which is both, like this one here, all of the 5 side lengths are all the same and all of the angles are the same. This is what we call a regular polygon, and in particular, this is a regular pentagon. Okay. This gives us the following. that we can calculate how big each interior angle is for a regular polygon. And the formula for this is it's 180 times n minus 2, because that's the total inside angles, if you add up all of the inside angles, and you divide that by n because there are n equal angles, okay? And again, this is as long as n is greater than 2, because you have to have a triangle. You have to have more than 2 sides for it to be a polygon, okay? All right, let's use this in some calculations. Find the measure of each interior angle of a 10-sided regular polygon. Okay, so our n equals 10 because that's how many sides we have. And our formula is 180 times n minus 2 divided by n. So let's plug our value of 10 in. So this becomes 180 times 10 minus 2 divided by 10, which is 180 times 8 divided by 10. And if I pull my calculator out, I get 144 degrees. Oops, there's no decimal there. Okay, so if I have a 10-sided regular polygon, each angle will be 144 degrees. Each interior angle will be 144 degrees. Let's use that equation in a different way. This time we're told that the measure of each interior angle is 165 degrees. And we're trying to find the number of sides. So we're looking for n this time. So our equation this time is going to be 180 times n minus 2 divided by n equals 165. And now I need to use some algebra to solve this. So I'm going to multiply the left side by n and the right side by n. These n's on the left cancel out, so I get 180 times n minus 2 equals 165n. And then if I distribute my 180, I get 180n minus 360 equals 165n. And then I can subtract 180n from the left and subtract 180n from the right. And I get negative 360 equals negative 15n. And I divide the left side by negative 15, and I divide the right side by negative 15, and I end up with n equals 24. So my answer is 24 sides. So a polygon that has 24 sides in it, each interior angle would be a regular polygon, that has 24 sides. The interior angles would each be 165 degrees. Okay. All right, let's talk about the exterior angles of a polygon. So here we have interior angles. Angle 1, angle 2, angle 3. Okay, the ones inside, call those the interior angles. The outside ones are the exterior angles. And that's angle 4, angle 5, and angle 6. So 4, 5, and 6. I'm going to do those with double lines in case I'm printing this out in black and white. Okay, now I'm hoping that you notice that angle 1, angle 1 plus angle 4, those are angles on a line, and together they equal 180 degrees. And the same for angle 2 plus angle 6. Those equal 180 degrees, and angle 3 plus angle 5 also equal 180 degrees. Okay, so this gives us, let's walk through this. If the polygon has n sides, at each side for each side, so this is a side here, there is a pair of interior and exterior angles which add up to 180 degrees. So for an n-sided polygon, there are n of those. So the total of the inside and outside angles is 180 times how many sides do you have? So 180 n. We have a formula for the sum of the interior angles, which is 180 times n minus 2. And we can distribute that out to make that 180n minus 360. And if we take this equation here and we subtract the 180 from both sides and add 360 to both sides, we end up with 360 equals the sum of the exterior angles. And I just want to show you a thing. Nope. Here, this one. Okay. This is a thing that I put together on, it's a website, it's a program called GeoGebra. I actually have the links to, I think all four of these are actually in the review package that I did up for you. I just want to show you this one because this is actually, this was a really, this visual really stuck with me when I saw it drawn somewhere else. And this lets you explore the exterior angles of a convex polygon. So starting with the triangle, and I can slide this. It's better if you hide the points because then you can see what's going on. But you can see that if you slide all of these exterior angles together like that, they eventually come close enough together, they make a circle. They make a full 360 degrees. Okay. If I make it a four-sided polygon, the four sides do the same, they do the same thing. They all go in and make a circle, okay? I can make it a six-sided polygon. And as long as I'm keeping, it doesn't work if I make a concave polygon, it needs to be a convex polygon. So now I've got six sides and six exterior angles, and there, they still go in and make a complete circle. They still make 360 degrees, okay? So, and then this button up here resets it to what it was when you started. Okay, so I just wanted to show you that because I think it's really, to me, it's a really a really helpful visual. To remind me of this rule, which is the sum of exterior angles of a polygon. Any polygon is always 360 degrees. And each exterior angle of a regular polygon is going to be, let's just come up here and look at this. The exterior angles, if this is a regular polygon, the exterior angles are all the same, right? So you would take the 360 and you would divide it by 3. So it's 360 divided by n. So if it's a four-sided polygon, you divide it by 4. Five-sided, you divide it by 5. So let's look at some examples for this. Find the interior angle of a 9-sided polygon. So one method, which is using this sum of the angles, of the exterior angles, is each exterior angle is 360 divided by n, and in this case it's 360 divided by 9, which is 40 degrees, and the interior angle plus the exterior angle equals 180. So the interior angle plus 40 equals 180. So the interior angle is going to be 180 minus 40, which is 140 degrees. So that's one way to do it. The other way to do it is to use the formula that we had up at the beginning, which is that the interior angle is 180 times n minus 2 divided by n. So in this case, that's 180 times 9 minus 2 divided by 9, which is 180 times 7 divided by 9, which is 140 degrees. Okay. And you can use whichever method you like. I personally prefer method 1 because I don't have to memorize a formula for that. I just have facts. I know that the 360, all of the exterior angles are going to add up to 360, and if I have 9 of those, I can divide it and I get 40, and then I know that the interior plus the exterior equals 180, so I just subtract the 40. The formula is probably easier to use, but then I have to remember the formula, and I hate remembering formulas, so that's just my own personal bias. Okay, example 4. What type of regular polygon has an interior angle 3 times the exterior angle? So I'm going to draw a picture for this because I don't know. So I'm just going to draw part of a picture here and here. So just going to do some random polygon with some exterior angles. So if the interior angle is 3 times the exterior angle, I'm going to assign a variable to the smaller of those two, which is the exterior angle. So I'm going to call this E for exterior angle, and I'm going to label that here. So that's the exterior angle. And the interior angle is 3 times that, so it's 3E. So this is 3E, okay? So what do I know about my E and my 3E? Well, I know that my interior angle plus my exterior angle equals 180, okay? So I'm actually going to write that down. So the interior angle plus the exterior angle equals 180 degrees. If my interior angle is 3E and my exterior angle is 1E, that equals 180 degrees. So 4E equals 180. So E equals 45 degrees. So that's the first part. The exterior angle is going to be 45 degrees. And by the exterior angle formula, which says that 360 divided by n equals the exterior angle. 360 divided by n equals 45. Then 45n equals 360. I'm cross multiplying here, and then I'm going to divide that by 45, and I get n equals 8. So when it asks what type of regular polygon, the answer is an 8-sided polygon, which is an octagon. And I do actually have a poster on the wall that has the names of all the polygons, how many sides they have. I wouldn't expect you to know anything past 10. You don't need to know what a 14-sided polygon is, but you should know octagon. Think octopus, 8 sides. Okay, what regular polygon has an exterior angle to interior angle ratio of 2 to 3? So that's weird. So let's write this down. We've got exterior to interior. So the ratio is 2 to 3. So if I make the exterior 2x, I don't know what x is, but it's 2 times something, and then the interior is 3x. right? That gives me a ratio of 2 to 3. And what I know is that 2x plus 3x equals 180 degrees, right? Because my interior plus my exterior equals 180. So 5x equals 180. So x equals 36 degrees. Now, that's not actually anything. That's not the size of one of the angles. I now need to go 2x is 2 times 36, which is 72. So that's my exterior angle. And since 360 divided by n equals 72, then n equals 360 divided by 72. So n equals 5. So it's a 5-sided polygon, which we call a pentagon. That's my answer. What kind of polygon? Has an interior to exterior, or sorry, exterior angle ratio to, sorry, has an exterior angle to interior angle ratio of 2 to 3. Okay? All right. Oh, here's names of the different polygons decided based on how many sides it has. Okay. I mean, you probably know quadrilateral, pentagon, hexagon, heptagon. You might not know, but you've taken chemistry. Hepta comes up in that. Octagon, nonagon, and decagon. Deca, think decade. Okay. And then if it's just an unknown number, it's n-gon. Okay. All right. Oh, and then you get some practice. I do want to, so they start off pretty straightforward using the formulas that we have. And then you get into these kinds of problems where you have to solve it. You have to use these tools to figure things out. So what can I want to do an example for you of one of the more difficult ones. Oh, that's it. Okay. Let's go back. I'm not gonna, there's not that many examples, so I'm not gonna do any for you, but let's just look at this one for a moment. This is a regular pentagon, so it's telling me that all of the sides and all of the angles are equal. So I can use my exterior angle formula to figure out that, and if I know that this one is the same size, all the inside angles are the same, so I can figure that out. Okay, so just work through the process. Okay, that's it. That's it for the video. Have a great day. Bye.